Hi, everybody. My name's Darron Froese. I'm at Darron on Twitter and GitHub. And when I'm not crawling through an underwater wreck or freezing in the Great White North, I'm an SRE for Datadog. By the way, these slides will all be posted on my blog after the talk, so if you missed something or can't read it, just go and grab it. Datadog's journey into integrating Consul into our environment started near the end of 2014. We had about 400 VMs on AWS. We had a 4-year-old code base. We were cutting apart our monolith, and we had rapid growth kind of across the board in clients and staff. We were having problems and kind of some pain around service discovery and configuration management. We had gotten to where we were by doing things a certain way, but we couldn't do things that same way anymore if we wanted to grow further. In order to scale to the amount of traffic that we're seeing, we needed to add many machines to share the load across our platform. As the above quote notes, you can get pretty far, in our case up to 400 machines, but it was increasingly getting cumbersome to manage those lists of IP addresses. We needed a better way. By the way, there's a great article there as well, and I'm going to try not to turn my head because then the mic goes away, but there's a great article over there that's worth a read even though it's a couple years old. So service discovery at that time was a hybrid. We had a ton of chef searches, and those took 30 minutes to update. Plus we had large numbers of manually managed IP addresses. Those environments files were some of the most changed files in our code base. And there was nothing really wrong with it. It was how we did it, but it was getting harder and harder to manage. And as you can see from the graphic above, the services that we were extracting out of our monolith and adding to our application to keep up with our growth and demand were growing. We weren't quite to SoundCloud levels, like we didn't have 800 microservices, but we're getting there. If we were to prepare for the future when we all move to containers, pods, and unikernels, there's just no possible way to keep all the locations of all of the things in a single static file. Plus, it was really error-prone to manage that file, and it was getting really difficult to merge. We could see the writing on the wall. So I had first used Consul in June 2014 as a backing store for environment variables for my Docker project Octohost. I was only using the key value store at the time, but I knew that it had an integrated and opinionated service discovery framework built right in. So we got approval to make a plan and take a quick spike into seeing if Consul could meet our needs. And here I am 18 months later, still sort of on that quick spike. At the time, I thought that our desired end state was very simple. We wanted to register and provide a catalog of services inside of our cluster, and we wanted to make that distributed key value store available on every node in our cluster. Unfortunately, for people who like to complete things and move on, those two little goals led us to almost an infinite amount of yak shavings and rabbit trails in a quest for infrastructure nirvana. So some of you might not know what Consul is, and that's great. Thanks for coming to this session. But I'll just quickly go over in a nutshell. Consul is a tool written by the fine folks at HashiCorp. It has a distributed and strongly consistent key value store that you can access and change on any node. That key value store has flexible ACLs that you can lock down as needed. It has an opinionated discovery framework that's built right in and ready to go with the DNS and HTTP endpoints. You can register a watch against keys and then receive those values as they change. You can also create locks around any processes or key, and as long as you keep the connection to the server, you get to keep the lock. It also has some remote orchestration and job execution components. It's really quite cool. So Consul has server nodes and agent nodes. Sweet. And you run Consul on all nodes. The binary is identical. The only change is the configuration. The server nodes participate in the Raft consensus protocol to keep things consistent. It's how they agree in this distributed system. There's always a single leader out of those server nodes. And if the leader slows down and stops responding, the other server nodes have an election and appoint a new one. Now, a leadership election is not a big deal, at least with Consul. It's not like a Postgres failover where you actually have to do something. It's hands-off and happens automatically. If you have time and want to learn more about Raft, the link at the top of the page is where that animation comes from, and it's got some great explanations as well. So given that Consul is awesome, and it is, we still weren't sure if it would work for us and if it would help. How would it fit in our environment? Would it work given our needs? And how would we end up using it? We didn't have a clear idea because there wasn't much written about it at the time. So we rolled it out into staging. There were about 100 nodes in staging at that moment, and we used M3 mediums for the server nodes. So phase one was pretty limited. It was only an initial deploy of the server and agent nodes, and we had some limited services, and we're exploring the service catalog. We really wanted to see how would it act in our environment, and would it interfere with anything? We quickly found that no, it didn't interfere with anything. It took a small amount of memory, between 15 and 60 megabytes for each agent node. And everything seemed calm, maybe a little bit too calm. Now, given that I work for Datadog and Datadog monitors things like Consul, this is the part of the talk where I say you need a way to monitor Consul if you want to roll this out. At Datadog, we have a philosophy of monitor first, which means if you can't monitor it, it doesn't get rolled out. Well, most of the time. Over the next couple of weeks, we built a Datadog integration to monitor Consul. We learned how to break it. We learned how to fix it. We figured that it likely wouldn't break the world when we rolled it out into production. So we shipped it in the state that it was, enabled, but not really being used. Sort of a dark launch. It was running and active on every node, but it was not being utilized except in a very exploratory sense. Now, I was tasked with some rules. This wasn't yellow to the max, right? At this point, Consul was not allowed to be in any critical path. An outage with Consul could not take us down, and if we were going to depend on something new and bleeding edge, we had to have our eyes wide open. We had to trust it. So at the time, there were about 400 nodes in production. So we spun up 5 M3 large nodes and started adding agents. 3 didn't seem to be able to handle it. We had way too many leadership transitions, and we wanted to have enough cushion to survive more than a single failure. When everything finally got rolled out into prod, it was nice and stable. Now, during our explorations in staging, we had discovered what we considered to be the 2 most important metrics that tell you if Consul's operating correctly. And 1, do I have a leader? 2, when were the last leadership transitions? Was one recent? So overall, these metrics tell you whether or not your Consul cluster is healthy. If you have a leader, well, things are good right now. And if you've been having lots of leadership transitions, even though they're hands-off, it's probably not a good thing. It can point to problems. We'll come back to these because these metrics play a prominent role in today's story. So now that we were live and on prod, what did we do? Well, one of the first things we did is we added a Datadog service that was installed on every node. We wanted to use the Consul service catalog to give us an accurate and up-to-date list of all of our nodes and their capabilities. So we used Chef to install the service as a small JSON file. And we have an example above. We also used Chef to add all of the nodes' roles and availability zone to the service as tags. Now that we had a complete picture of all of our nodes, we could do fun things like this. We could use a command we named SSH to roll, which would pick a node from the catalog and send us there. You could even do it from your local machine. It's pretty handy. So we also wrote another command called host by role to find all of the hosts with a particular role. And this is an incredibly useful and now one of the primary ways that dogs, Datadogians, connect to and move around our cluster. I can't believe I just said that. At Datadog, we already have Capistrano in place to do some orchestration and maintenance across our cluster. Consul exec can be very useful as well. It can run any command you want on any node or group of nodes. We are limiting the above command to our Consul server nodes. The catalog of nodes is always up to date. There's no manual process to update the catalog, and it's super fast. Things that can take many minutes with Capistrano can be reduced to 5 seconds or slightly more with Consul exec. Now, we aren't super happy with some of the current security trade-offs with Consul exec, as I hear the laughter. It's not very easy to lock down completely right now, and it's kind of a parallel security mechanism for us. So it's generally disabled. One pro tip, don't tail a larger active log file with Consul exec, because each line that you read has to go through the RAF consensus to get to you. And if you do that, it melts down your servers. All 5 of them, or however many you have, they melt. So HashiCorp knows about that, and they're hopefully looking at some sort of solution. But yeah, just don't do that. So remember that strongly consistent key value store that's installed on every node? Well, it turns out it's really handy to have a globally available data store available on every node in your cluster on localhost. We wanted to use this for some of our configuration data, but we also wanted to know who made a particular change and when that change was made. Turns out somebody already built most of this and open sourced it, and Git to Consul works great. So we took Git to Consul and we created a new repo that has selected configuration data that's widely used across our stack. It's a very popular repo at Datadog. Who knew? If you build something that's easy to use and fast, people will actually use it a lot. Every 60 seconds, Git to Consul checks GitHub if it's up to see if there have been any changes to their Git repo, pulls and merges the changes to the KV store using Git. Consul then distributes those changes to all nodes, and then the processes we have in place act on those changes. So it's given us a whole bunch of quick capabilities around reactions and flexible configuration. It's also capable of sending a broken config file to every node very quickly. It's a tool with a very sharp edge. So as we were using Git to Consul and Consul config, we felt, and because of how we were using and abusing Consul, this exposed what we felt was the weakest part of Consul at the time. That weakness was how Consul reacted when reading from the key value store at a high velocity. Consul's leadership transition mechanism is tied to latency. After the other servers don't hear from the leader for 500 milliseconds, for whatever reason, the other server nodes kick it out and elect a new leader from that group. The old leader comes back with its tail between its legs and promises to do better next time and joins with the others in waiting for its next turn. When you read from the key value store at too high a velocity or from too many locations at once, Consul 0.5 has a tendency to freak out and have those leadership transitions. Each leadership transition takes about 5 to 10 seconds to be complete, and during that time, the KV store is unavailable for reads and writes. As you can see above, that graph from January to May wasn't that awesome. And in all fairness to HashiCorp, and as we discovered later, some of this was self-inflicted. So we adjusted our code, we made it more tolerant of those sorts of quick interruptions, and we moved along. Here we are at the end of May, and as you can see, we're growing in all areas as we start to use more and more features of Consul. By this time, we're getting serious with service registration. We're only up to the letter D here, and we got a lot of them. Many of our services are being registered, and we're playing with how to use the various discovery mechanisms. So there's a simple HTTP API built into Consul that can answer many things about nodes and services that are registered with it. It's flexible and really easy to use, but to use it in a few places would require some significant re-architecture, and we just didn't want to spend the time doing that at that time. For the most part, we decided not to use that discovery mechanism as our default. We decided to primarily go with the DNS interface, and at least for inside of our application, and to connect to our microservices. It's simple and flexible. If you know the name of the service, you can very easily get a list of IP addresses and ports to connect to from any language. And as with anything to do with DNS, it obviously has its own drawbacks. And there's some strangeness with some libraries and Java, but it just works the vast majority of the time, at least for our Python and Go-based stack. Our newest service, the custom data store and metrics service that we launched last summer and fall, well, the DNS interface is the only way to access them. There's no other way. And as we add additional instances to handle the load on those services, these new nodes are added into rotation and balanced against. We were worried about these services being unstable, flapping in and out of the catalog. What would that do to our app? Would that happen because of Consul? Would the health check mechanism work like it was supposed to? So we did what many pragmatic SREs do, and we cheated. For some services, we made it never fail by calling bin true every 60 seconds. And others, they removed the check altogether. In still other cases, like with Cassandra and Kafka, we use proper health checks at a decent interval. And I'm happy to say that service flapping isn't generally a problem. Well, at least it's not a Consul-related problem. If your service is flapping, in our experience, it's because your service is flapping. It's the Consul mechanism that does this is very reliable. When there's a Cassandra-related issue that's rolling through the cluster, we can see one node at a time dropping out and coming back in, but that's a Cassandra issue, or whatever the JVM is doing at the time, right? It's proved to be a very reliable and stable mechanism. So another quick pro tip, Consul has a concept of a data center, and within that data center, every single node needs to be able to talk to every single other node on TCP and UDP over a variety of ports. If you don't have all the right ports and protocols open, you will see flapping for sure. When you have a high velocity system that ingests millions of data points per second, using DNS has always seemed to be a very risky endeavor. In fact, before Consul, we didn't use DNS internally at all. It was always bare IP addresses so that we didn't have the lookup penalty. And given Consul's tendency for read-induced leadership transitions, we were a little concerned that adding millions of queries per second to hundreds of machines and what that would do to our cluster. So we did a few things to help mitigate this. First of all, we installed DNS mask in front of Consul so that we weren't querying Consul directly all of the time. DNS mask will intercept anything with a .consul domain name and direct it to port 8600, which is the port that Consul Service Discovery DNS listens on. Secondly, we added a short 10-second TTL to all of our Consul services. Consul sets the TTL to 0 by default, and that was just a little bit too short for us. We also looked at creating a host file based on the contents of Consul's Service Discovery database. So we looked into the existing bag of tricks around Consul. We grabbed Consul template, also a HashiCorp product, and started with that. Our plan was to build the host file on each node and load it into DNS mask directly. It seemed like the most straightforward option, and it would have been great. But even in our staging environment, it was chaos. Everything was on fire. When Consul template was updating, each node was querying Consul's catalog. It was putting so much read pressure on Consul's data store that it was pretty much eternal leadership transitions. Multiply the nodes by the number of services, and I lost my mouse. There it is, sorry. By the number of services and the number of records for each service, and yeah, doing it that way was not an option. To be clear here, this wasn't Consul template's fault at all, and as a nice side note, Consul 0.6 has largely solved this for us. But here we were in May of 2015. Consul 0.6 was still a twinkle in Armand's eye, and we weren't willing to wait until December. So we got to thinking, let's build this on one node. Not all of them, it's all the same information anyways, and use the key value store to distribute it. We'll use one of those really nifty Consul watches and grab it when it changes. And it worked. It worked really, really well. We weren't seeing any problems at all. There were no leadership transitions, nothing. It was super stable. We very quickly found out that without rate limiting this process, reloading all of your Consul agents on each node will cause their service to be dropped in and out of the catalog. And when you're doing an update of Consul on each node, that tends to happen a lot. So those graphs show the automatically generated host file with all 600 of the nodes at the time going in and out of the catalog 40 times a minute, or about once every 1.5 seconds for about 30 minutes. It was a super stressful time for myself without rate limiting, so I very quickly added rate limiting. But we figured out one thing that surprised us, and that was there wasn't a single leadership transition over that entire time frame. We had pushed Consul past anything that we had pushed it before, and it operated well. On one side, we were having leadership transitions every single time we committed to our Consul config repo. It was only one or two, but it still happened every single time. And on the other side, we were throwing a 40K file into a strongly consistent data store every 1.5 seconds and distributing it across 600 nodes, and Consul didn't crack under the pressure. It didn't even blink. And that was an important clue for us to learn about dealing with Consul. The very next day, this commit, which has been anonymized to protect the blameless, sailed into our configuration repo. And JSON files are now pretty and standardized. And that's, hey, somebody took it upon themselves to clean it up and lint everything, and that's normally a great thing. But this isn't. This was the next couple of hours while we valiantly battled against all the forces in play. So Git to Consul would grab the changes and try to update some keys, then it would crash, Consul would pass the leadership baton, and it would just do that over and over and over. Way too much read pressure. So in the end, we ended up having to disable Consul on a subset of the nodes in our environment and force Git to Consul to update everything so that we could get the KV store completely updated before Chef slowly restarted the nodes that we had disabled Consul on. So what have we learned here? Well, one of the first things we learned that it's hard to be one of the early adopters of a new distributed system. There's no Consul Stack Overflow where I can go steal some magic incantation. At the time, there was really very little information available about real-world usage of Consul and how people were actually deploying it. Another thing we figured out at the same time was that, something that I had suspected for a little while, is that we were sort of doing it wrong, blamelessly, of course. We had about 100 tiny keys, and these were the keys that were being read at an extremely high velocity across our whole cluster. We were sort of DDoSing ourselves. And this was not the sort of problem that showed up in staging, no matter how hard we tried. We just didn't have the same scale. But we didn't know that until it was too late to change quickly and easily. So just to remind you of the facts as we know them, Consul servers throw a coup d'etat when the leader can't keep up. It can't keep up because it's doing all of the things all at once. We can do more of those things all at once with bigger CPUs. We're in Amazon Web Services, and they like selling us bigger CPUs. And we had just raised a Series C, so why not? We upsized our servers. We deployed these new and bigger servers one by one and put the old ones out of their misery. And things were made right again. They were still happening, these leadership transitions, but nowhere near as much. Now, we just took a little detour and talked about leadership transitions caused by read pressure. And you might be asking, well, how did DNS mask and the host file work, Darren? Whatever happened with that part of the story? Well, to let you know, because I know you're all very interested, it worked really well. And as you should be able to see above, we added, well, maybe not, it's pretty low, but we added an additional host file to DNS mask. And we added a local TTL to the items in that host file. And DNS mask is one of the few things in the known universe that actually honors DNS TTLs. And I'm exaggerating a little bit, but not too much. It also works great with Consul. So in testing, you can see it only forwarding the first request to Consul, then serving the cached answer for 10 seconds, and then going back to Consul to re-resolve. And it's pretty nice to see software that does what you would expect and hope it did. It's also really quick. I was trying to measure with Dig, and I kept getting 0 milliseconds, so I wrote a small tool to query for me. For items that DNS mask forwards to Consul, it's between 600 and 700 microseconds to get a response. For items it's cached due to the Consul TTL, it's usually around 200 microseconds. And for items in the host file, it's between 100 and 200 microseconds. It's fast enough for us at the moment. We wanted some stats, so I wrote a small DNS mask stats gatherer and hooked it up to Datadog. Across our whole cluster, we're doing about 3 million DNS queries per minute, about 50,000 a second, where the data is coming from that locally generated host file. And again, across our whole cluster, we're doing about 25,000 requests that go directly to Consul per minute, or about 400 a second. So that Consul-based host file has helped us move approximately 49,600 queries per second onto DNS mask, which is helpful especially given Consul's proclivity for read-induced lead transition. So we like DNS mask. We're big fans. I guess it's how awesome is it? And at that point, it was 119 times awesome. So the way we have it, DNSMask will answer queries from the host file first. And if there's nothing there, then it'll search console. And the above graph shows what will happen when a failover removes a console DNS entry, but the new entry wasn't inserted immediately. We had a little over 1 million requests for that same domain name during that 1 minute time of the failover. And that went directly to Consul, and Consul was good, actually. So even though we had been having some success with Consul, we still sort of tiptoed around. People were a bit scared. We were only at 600 nodes at the time. What would happen when we grew further? Internally, there were some concerns as we scaled, and some teams couldn't trust that Consul would keep up with our growth. A parallel service discovery app based on Zookeeper was written and deployed as a test for the day that some people were sure were coming. And I honestly wasn't sure either. The next month, when we hit 700 nodes, it seemed that the fear was warranted as nodes started randomly going deaf and mute. They couldn't talk to the servers. They didn't see the updates we were placing in the key value store. They lost their console locks and their services disappeared. That was, the worst. When we bounced console on those nodes, usually it fixed the problem, but that gets old after about 5 minutes. And the biggest problem was that I couldn't duplicate the problem reliably. I could see the grumbling in Slack whenever it happened. Shortly after this started happening, I was in the New York office for the week, and I heard someone mentioning that it was deaf again. So I immediately went into full Brendan Gregg mode, and I was finally able to duplicate it reliably. And then it cleared up, of course, right? So I did what we normally do at Datadog, and I made some graphs. I wrote some code to watch the URL that exposed the problem, and I waited. These graphs and a large amount of Wiresharking helped us to track down what was happening. So a server node or nodes were losing their connection to the leader. And so the agent nodes that were connected to them were also deaf and mute. James at HashiCorp quickly found and fixed 2 deadlocks in the underlying multiplexer code that were helping with this problem. And that helped a bit. They also fixed a bug that spun up hundreds of extra connections in certain circumstances that our load and usage pattern helped to expose, but it was still happening. The last puzzle piece dropped into place when James from HashiCorp asked me about the Rides the Rocket Zen Linux kernel bug that we had thought we had fixed everywhere in our environment, but clearly hadn't. It was still happening, and it was interfering with server and agent communication. A couple days later, that bug was totally eradicated from our systems and prevented from ever returning through copious application of Chef Foo. And I held my breath, and the GitHub issues that our team had filed internally remained open, and the parallel discovery system ran alongside Consul. But the tide had turned, and the sentiment had started to trend in the right direction. That takes us up to October. We're fluctuating between 800 and 900 nodes as we're retiring some services and we're adding some new ones. Kafka is one of the most important pieces of technology inside of Datadog. All of the data, approximately 1 trillion pieces per day, go there, and all of our consumers pull from Kafka to process that information. In October, we used Consul config to swap out our primary Kafka cluster without so much as an external peep. It was pretty cool. We also started using Consul events, and they're sort of like Consul exec, but with predefined actions, so they're a little more secure. The apt update watch shown above waits until it receives an apt update event. Then it determines if it's seen that event before. If it's a new event, it runs apt get update. It used to take a long time to do this across our production infrastructure using Capistrano in the order of 20 to 30 minutes. And if a single node was removed during that time period, it would crap out, you'd have to start all over again, and I would want to blow my brains out. But that was what it was. Now, it's down below 60 seconds in production and about 10 on staging, mostly waiting for S3. We were also using a Consul lock for a number of processes. So with Consul lock, you can run some less than highly available applications with a sort of hot spare failover. In this case, we normally run 3 instances of any particular job with only a single one active. And when that one would decide to take a rest or crash, then one of the remaining processes would take over. in order to make sure that there's always at least one job working and active. It works pretty well. We have a few of those running at the moment. Git to Consul runs under this. Our Consul DNS host file generation system runs under this as well. Here's an example Ubuntu upstart file that works with Consul lock, and it's pretty easy to get a little bit more reliability for a single process if needed. When the leadership transitions grew, we bumped up the size of our server nodes again. And now we see a leadership transition every few days, and that's about it. And this is one time where money bought happiness, at least my own personal happiness. One important note in this saga is that at no time during this entire period was there ever a Consul outage that was caused by Consul, at least that we could determine. And when we had a Consul outage, they were largely invisible to the outside world, but because of how we had architected it and the constraints that we had operated under earlier. We had a 3-minute outage early in March due to a packaging and orchestration problem. And we had one outage in July due to poor documentation, and somebody who shall blamelessly remain nameless again restarted all of the server processes at the same time. And that's pretty much one of the only no-nos with Consul. You know, as a pro tip, don't do that. So Consul has been super solid. In fact, there have been more than one time where some sort of network partition in AWS, imagine that, has made some of our other clustered services unhappy, and Consul hasn't required any intervention to get back into a good state. So here we are at SREcon. It's April 2016. And what can I say we've learned about Consul over the last year and a half? Well, no matter what you thought you heard during the presentation, Consul is flipping awesome. It acts like an incredible data center backbone with these helpful primitives that are available on all your nodes. I'm a total fanboy, and if you can't tell already, I love Consul. I don't get any kickbacks from HashiCorp if you use it, but you all should, and even DevOps Borat loves it, obviously, so it's got to be good. Monitoring it as you deploy and operate it is not optional. It really should be a no-brainer, and I just so happen to know a great group of people that can help you with that if you need it. So if you're starting out, make sure you use 0.6. And if you're not there yet, find a way to upgrade. It's a single binary, and it is worth the upgrade. The HashiCorp team took all the community's feedback and totally rewrote the underlying storage engine. It solved all of our read velocity issues. They also fixed a bunch of bugs and added a whole bunch of cool new features that I don't even have time to talk about today. The new server and client binary takes about 1/3 of the memory. The servers are about 1/4, actually. And when was the last time that a new version of software actually used less memory, right? The red line there indicates where I finished upgrading all of our main servers. And as you can see, the lines are lower, and that's better in this case. So Consul servers really love a sizable CPU, and so make sure you feed it the right size of machine. If you're in the cloud, make sure to upgrade CPU speeds until your leadership transitions are rare. And if you're not in the cloud, get your PO in and get yourself some new machines racked until, again, the leadership transitions mostly disappear. As always, your mileage may vary, but there are some example sizes here on the slide. You might be able to get away with some smaller nodes due to the changes with 0.6 that I talked about earlier, but they're here for reference. One thing that has been emphasized through this entire process is to architect for failure better. Consul is a distributed system, and you don't have the luxury of having everything on one machine. Connection problems will happen, and nodes will drop out. Adding retries to your connection routines, adding exponential backoffs, and circuit breakers will help to make your stack more resilient. And obviously, this isn't a Consul-specific recommendation, but it was something that really pounded into us when we were dealing with last year's shenanigans. And if you're inducing constant leadership transitions with the velocity or volume of your reads, you need to upsize your server nodes and or change how you're doing these reads. For example, if you're running an app server and that app server spins up n number of processes, well, it's really helpful if you can avoid having each process separately talk to Consul. If you make efficient use of your Consul connections, it goes much farther. If you've got a number of machines reading all of the keys all at once, you may end up having a lot of pain like we had. One thing we're looking at now, hopefully next week, is we're using fewer and larger keys so that we don't have as many keys to read from. Not anywhere near the 512 kilobyte maximum. I think that's crazy sauce. But having lots of really small keys was the problem, one of our problems that we had that was self-inflicted. Another thing we decided early on was to use the available ACLs to lock down that key value store so that changes were only coming from data feeds that we could audit and examine. If your configuration can induce a behavior change, and its configuration, so it probably should be able to, having it available as a free-for-all for anyone with a connection to the KV store is a recipe for disaster. So lock it down and make those configuration changes auditable. Consul watches are powerful, and it's how we distribute data using the key value store efficiently, but they can fire a bit too often. I have a small Go utility that I wrote that we've been using to make sure that they only fire when they're supposed to. It tracks the state, that the time that the last watch was fired, and then it won't refire it if it's still in the same state. It's called Sifter, and it's available on GitHub. We use it in production at Datadog, and it's worth a look. My last tip is pretty key here. If your output isn't unique and you can get away with it, don't build your configuration from Consul data on every node. Build it on a single node, and then use the key value store as a transport mechanism. That's my last tip, but related to that last tip, I have one more thing for today. The last 18 months have been a huge learning curve for us working with Consul, and transporting configuration files using the key value store has been a pleasant surprise. It's fast, it's stable, it's reliable, and we've steadily been revising how we do it. As are a lot of the tools that we write, the first version was written in Bash. The second version ended up being written in Ruby, and our third version, and the latest one, is written in Go. We've been using it in production now for about 5 months, and it operates tens of thousands of times per day. It's been a lot of fun for me to develop. It handles the delivery lifecycle of inserting configuration into the key value store and reading and delivering that configuration on each local node. We also have a chef cookbook that helps to create the Consul watches that are needed for most efficient use of the system. We call it KV Express. It's a tiny Go binary. It handles inserting and delivering of files through the key value store. It emits metrics and events. Imagine that, metrics company. Whew. So that you can audit and measure what's happening. The file that's uploaded is the file that's delivered. We only use the finest of hashes to make sure that the file has made the journey intact. No MD5s here, we just straight SHA-2. It's efficient, and if the file doesn't change, it doesn't reload. It's optimized for safety. It won't write a blank file and screw up your service. And we also can run commands after the file is reloaded. It's also super fast. Once it triggers from a Consul watch, it's approximately 500 milliseconds to deliver a 40 kilobyte file to 1,000 nodes. Now, the stats are weighted a little, most heavily under 300 milliseconds, but there's always stragglers that make my histograms look pretty poor. I originally tried to measure the whole process from start to finish based on syslog timing, but that was foolish. Everything was happening in a single second. So I ended up adding some higher precision logging, and inserting into the key value store usually takes about 100 milliseconds and under. Delivery from the key value store takes less than 300, but often closer to 100 milliseconds. Another thing that we do when a change is uploaded is we throw an event to Datadog. And so we can audit and see what's happening. Those events are shown on a timeline. They can be graphed, measured, you name it. In this case, we're showing a new Postgres node being added, and I think we're getting rid of a Kafka node there. So the metrics it emits are pretty comprehensive. Number of bytes in a file, we want to make sure we don't hit that maximum. Number of lines in a file, a zero-length file is probably bad, right, just in general. How often it's firing and how long it takes. We also emit some panic metrics when the checksum looks like it's not correct, when it can't connect to Consul, things like that. It's available on GitHub, and so give it a try and let us know what you think. We've also opened up a chef cookbook that has some helpers to work with it. And if the internet gods are smiling, we have a very quick demo. So I spun up 1,000 nodes this morning in US West 2 because we don't use that. Oh, crap. Okay, give me 1 second, sorry. Thank you. So here we go. So we have, like I said, we have 1,000 nodes in Oregon at the moment, all shown as KV Express demo. And here is some of the metrics that were kind of emitted while it was starting up. So we can see here as it's starting up, it's getting a larger and larger host file that it's distributing to all the nodes. In the end, again, there's about 1,000 nodes here. The time for it to make those changes also seems to be sloping up at a nice linear kind of graph. File size goes up. So let's kill a couple nodes just for fun. So let's kill these 50. Yes. So what's going to happen now, as soon as AWS API decides to respond, is it's going to kill all these nodes. All of these nodes will then disappear from the Consul service catalog, which will then create a new host file, which will then distribute it to all the nodes. And it should only happen once and maybe twice, based on the timing. And then we get to see some more metrics as they come in. Yay, there we go, it worked. Sometimes things don't happen as fast as you would like in a live demo. So here we go. We have it just uploaded a new file. That file was about 1,000 lines, and it didn't take very long. It was quite quick. It was under 400 milliseconds to distribute that to the other 975 hosts. And Consul is kind of going along. Send some data, but it's operating quite well. And our DNS system is currently idling along here. This graph shows how many local queries there are per minute of that local host file, and then any other DNS queries that box is running at that moment. So that's a quick demo of what KV Express can do, especially when it comes to helping your DNS infrastructure. Are there any questions at all?
Great demo. I'm glad it worked.
Yeah, me too.
So have you enabled SSL on your Consul environment? And if so, was there
Not yet.
any? Nothing.
Not yet. I would like to. That's on my list. We don't have anything in there that's too terribly secret. It's just, like I said, it's configuration data that our app uses to operate against. So not
That
yet.
was actually my second question too.
Oh.
How do you handle secrets? But
Well,
not, then.
when I get a chance to, I want to look at Vault because we already have a very nice and stable, and Vault's been maturing. But yeah, at this time, again, we're keeping stuff out of it and waiting for Vault. So.
Hey, so before you ended up going with DNS Mask, did you investigate caching over the HTTP API at all?
Question was, and I'm just going to repeat them for the video, is that do we investigate using the HTTP API instead of DNS? And the really short answer is no. There were just too many parts of our app that we would have had to do too many changes to that we didn't want to. So.
You did talk about the configuration part of it. Have you done the orchestration part of it also with using Consul?
We have, so the question was, we've been using it a lot for configuration, but have we used it for orchestration? And right now, because of some of the security problems with Consul exec, we've kind of stayed away from it. We've used some limited Consul events, which allow for some of those things. But at this point, we haven't gone too far into it. So.
Hi, we're actually in the midst of deploying Kafka right now. Do you have any recommendations while you configured Kafka with Consul?
Kafka and Consul, so the question was, do we have any recommendations about how to configure Kafka with Consul? And the short answer is, Kafka's sort of out of the Consul loop at the moment. So no, I don't really have any good recommendations. We're looking at it because right now our Kafka configuration files are done with Chef. And after I go to the Consul Summit in 2 weeks, I'm hoping to have more information to move down that way.
So after you built the DNS mask solution for caching and using the host file, it seems like you're still using DNS queries that go directly to Consul instead of all of them hitting the host file. Is there a reason for that?
There are some, so I choose, so the question is, there's still some DNS going to Consul. Why? I guess, in short form. So I choose which services that I want to include inside the host file because, so say our Datadog service has tags for every role and every AZ, and it would actually probably double or triple the size of the file. And because nodes are being added and removed all the time, there'd be a lot more churn. So we've chosen to keep those out of the file. And those are used for like SSHing to a node or grabbing all of the hosts. So we keep those out, and so those are probably most of the 25,000. That and loading the Nagio server we have as a backup and loading a few other things that are just not cached. But yeah, so that's kind of why. We're worried about churn, but at this point, we could probably enable all of them and it wouldn't be a problem with Consul 06. We just haven't had a need to.
Okay, thanks.
I had a question. You said Consul's multi-data center. Are you using that for like cross-AZ?
So the question is, Consul is multi-data center. We're using it for cross-AZ, and the answer is yes. We're in 3 AZs in US East at the moment. We're not using it multi-region at the moment. So,
what are the things you would look out for when you do go multi-region?
You know what? They're actually quite separate. Like the key value stores are not copied from region to region. You would have to do that manually. In our case, what we'd probably use is we'd use another Git to Consul in the other region and just pull the same data. I would be concerned if you start to look at doing multi-region failover and some of the latency that you would, obviously invoke if you're, going too far. But from what I've seen so far, or what I've read about and what I've seen, the multi-region stuff doesn't seem to be too bad. Just don't do things that expect it to be instant, like 2 milliseconds kind of thing.
Thanks.
So when you do configuration pushes, how do you handle things like rolling restarts?
So the question is, how do we handle things like rolling restarts? And right now, that answer is unfortunately a little bit poorly. I built a mechanism to do canary rollouts of configuration code, but that doesn't quite work with some of the older mechanisms we have in place. We're looking at transitioning all of that config code to that newer mechanism. Before we had KV Express, we just pushed it out and kind of render it all to a JSON. And so that one I can't roll out in a canary mode. But the KV Express one, I can tag nodes, roll them out to that, then copy the key from one location to another. That's next on my roadmap.
Thank you.
Thank you.
Thank you for the demo. It's really cool. I was wondering if you've explored the use of an API gateway type patterns to sort of obviate the need for such a large scale service discovery so there's no ambiguity about where to go.
Would love to. I would love to do more microservices that are a little bit more micro-y. But that's not kind of the world I live in at the moment when we have a 4-year-old code base, we're extracting things, and right now this is where we are. So yeah, I would love to, but it's just not right now with some of our services. So thanks everybody. Let me know if you have any other questions.